So in the last meetups, we talked about the volatility or disk forensic, log management, and things like that. We covered a lot actually. So in this CTF, we would like to actually wrap up a little bit to see what we learn, what we can do. So the lab was designed to do in a way that there is an internet network. Here's the corporate network, the public-facing IP address is 172.16 and 52.203. So you may ask, hi, why it is not a public IP address? Why you are using a local IP address? Because I'm trying to simulate an attack. I can't let this vulnerable machine open to the internet and other hackers to compromise my machine. Although I have a bunch of vulnerable machines on the internet as a honeypot, but this is explicitly designed for the CTF. So obviously the attacker is supposed to be outside the firewall, but you can find it from the the logs itself. Assume that you have been reported that there is an incident happen on this network, and you have these three machines in your network, and your duty is to solve the problem, what's happened, and how we analyze some sample incident. So first of all, how we started to our incident analysis. First of all, where we should start to analyze our investigation? The answer is, come on guys, this is an interactive training. Just give me the answer.
The log file, the PCAP was very good.
Yeah, I mean, which machine first of all? Web server, right? Because the public-facing server is supposed to be the most risky ones, and then we can start from this one. So this one actually have a bunch of services. If you look at the folder here, let's take a look at it and let's analyze that. Assume that you're actually a incident responsible. You can ask questions to the individuals in the organization. But when we look at that, this is a web server. We have an init.pub folder and also event logs here, SQL profiler logs, and also memory and also PCAP file. So these folders gives us an idea that this is a web server first of all, and there is a SQL server running on this machine because we have a SQL profiler logs here, and also we have the memory and also the network capture. So starting from memory and also PCAP files, do you think it's a good idea? No, because those are binary files, and starting from a binary file analysis, it's usually not a good best practice. My prefer is start with the web logs always, because web application logs is easy to parse, easy to analyze, and then you can get a better idea when you analyze the log file. So that's why I'm going to start with the log files, and the web log files usually sits in init.pub folder and logs and the logs file directory. So actually in this case I make it as simple as possible. There is only one log file. In normal cases you will probably have a bunch of log files, so you need to analyze multiple logs together, but we already covered that. I want to keep this as simple as possible. That's why there is only one log file. Let's analyze and let's see what's in there. So how can I understand the structure of this file? First of all, when we face with something like this, we change the folder. I change the bash to the corresponding folder. Now I can take a look at that. How big is this file? It's 44 megabytes. And if I do the word count minus L, this file, there are approximately 250,000 lines of logs. So is this a good idea to open it with that Notepad editor? Definitely not. You should supposed to do it in a console, so you can filter out and then you can take a look at the Notepad. But we have a bash, and then it's not going to be a problem. So let's take a look at the header of this file to understand what kind of a log we are looking at. This is obviously an IIS log file. And in IIS log file, there are multiple fields: date, time, source IP, client to server method, client to server URI stream, client to server URI source port. Server port. Sorry, this is server port. This is not the source port. A source IP, server port. This is the client IP, and user agent status, and the rest of the findings. So. First of all, in the log file, web application log file, what kind of things that we should take a look at? So I usually prefer to look at for the usual suspects by using a regular expression. So here I am gonna look at some of the possible findings. So for example, SQL injection payloads like select, where, and even union, and also possible cross-site scripting things. So for example, XSS or even script, because if I see something JavaScript or script in URL, that means that somebody is trying to exploit a cross-site scripting vulnerability. Even you can search for executables and things like that to make sure that if there is anything like executable or command line injection and things like that. So let's get these things and then let's take a look at that, how we can expand our analysis. So I'm going to use, let's use head first, and then we can take a look at that. So here we have jQuery, it comes from scripts right here. And here we have union select something, that's interesting. I found something, of course, this is going to be a little bit, the sampling is not good enough. If I say word count minus L, that will be probably a few thousand, 21,000 log files. With respect to 250,000, 21,000 is reasonable. So you can take a look at these files. But what I'm going to do is I'm going to look at this one with less command to get an idea that what these guys are trying to do. So less is good option with respect to more, because more is actually filling up your command window, but this instead opening another virtual window, so it's filling up, and then when you quit that, it's going to disappear. So you can have you can scroll up down in your terminal window to see the previous results. So here, when we look at that, I see that there are a bunch of interesting findings. So for example, product category union select, product category union select. This is not something that I'm looking for, right? So if I scroll down here, I see a bunch of similar results. So this means that somebody is trying to exploit a SQL injection here. And interesting though, he gets 500. 500 means that this guy has found some possible vulnerability and also trying to exploit it in a way that can get a 500 or even 200. So both of them are dangerous thing. If we were talking about 400, it may not be a big problem, but 500 is your server is not handling this kind of stuff. So we can cross-check by looking at the event logs here. In the event logs, when you open that event log, you can see that there are 500 and there might be some stack trace, and that says, hey, this is supposed to be an integer or a string. It's not being handled. Here's the stack trace of that thing. So stack trace is not available in the log file here, but you can see that in event log. So, okay, definitely this guy have a bad intent. So the IP address of this guy is 172 right here. It's actually a little bit misaligned, but this is the IP address of this guy. So remember that client IP was the 11th column, I think. So 172.16.52.238 is the attacker's IP address. So this is interesting. I see that bunch of URL here, but I wanted to focus on this guy first of all. So this is the candidate actually. You can find by looking at more, but this seems to be first good candidate. Let me copy this IP address. Let's quit this one and let's grab this guy. And again, I want to use less here. So let's analyze this guy. So he visits our website at this time and the calls for the root, and then of course your web application asks for the bunch of the resources to render the website, and then he looks at the product page with product subcategory ID of 18, and then uses the search box here. And interesting though, he was getting 200 here, and here he gets some 500 result here, right? So, but I can't see the URL in this line. Why I can see that? It's post request, right? In the post request, you can see the body, but you can see the body of this thing in where? Into the PCAP file, right? And also you can take a look at the web application firewall logs if you have. Unfortunately, in this case, we don't have. But in your normal environment, you may take a look at the F5 log or maybe the Citrix Web Scaler log. So those guys can provide you the body of this post request. But for this now, we suspect that this guy found something while searching, and then he continues to take a look at that, and here, again, product subcategory 28, 28, okay, doing great. So here, interesting things becomes to happen. While he was looking at something, he suddenly decides to use this thing, and which is a interesting payload here. Definitely, this guy starts to taking a look at this something right here, right? So again, if I scroll down here, I see that he's playing around with product subcategory ID and getting 500 results. And if you analyze your application, you will see that there is a SQL injection vulnerability here. So if I scroll down here, I see a lot of things here. So that's obviously he is using SQL map to generate this content. It's an automated engine. Okay, let's figure out that what kind of URL he's getting out. So we see that the product.aspx is the one candidate that he asked for, but I need more of this one, right? So let's grab the URL that he is asking for, and it's going to be the first, second, third, fourth, and fifth column, right? Let's quick this, and what I'm gonna do is I'm gonna grab this guy, but I'm gonna cut my lock with space, and I'm gonna get the field fifth, and let's see whether we are in good shape here. Okay, so we're getting the URLs here. What I'm gonna do is I'm gonna sort this, unique this, and sort minus NR, which is going to give me all URLs that he is visiting, and it's going to give me the top, URLs that he visit. Okay, let's see. By the way, while this is doing the analysis, we can take a look at the. It's really long. Oh, okay, yeah. I know the reason why it's messed up my, bash here. Okay, so let me scroll up all the way down here. That's why I hate to print something to my console. Okay, anyways, so here, product.aspx is the favorite URL that he is visiting, and interestingly, slash and uploads, under uploads there is a shell.espx. So shell espx usually a common backdoor files, so I don't expect to see that actually. And also here search ASPX and things like that. So if I scroll down here, there are a lot of URLs that I'm not familiar with. Zoo, Zoom, Zoo, Zone Alarm, Zone. What the hell is this? Where is this coming from?
Probably we might be doing the brute force to find out.
Yeah, exactly. So trying to find out some URLs that might exist. So this is, we're going to take a look at that, but these are for decoy. So I just created a little bit noise to hide the real attack, but real incident responder can easily identify that the guy is using a Deerbuster tool to, find out all the possible URLs, but finally finds an exploitable vulnerability and uses that vulnerability. So, okay, so we understand that he finds something and also, use that URL to exploit something. So here's the interesting thing. Register, okay. Login is okay. And contact ASPX. These seems normal, but how about this? Test that too. And this is actually, by the way, this scenario is coming from a real incident case that I've responded. So when I see that test that too, that ASPX, that's interesting. And remember, he used the directory browsing, brute forcing, and I begin to think that this guy probably used directory browsing to find out some test URL that's not publicly accessible, and then use that to find out to do something. And then I begin to focus on, okay, let me take a look at this test to ASPX. What does it look like? Okay, so I'm going to open another window. Actually, I don't want to lose this window. Okay, and then let's say grab this URL and in this log file, and there will be 7 actually, but I still prefer to use head. Okay, so here looks at the test.to ESPX with Deerbuster here. That's what we expected. And then when he finds that and he gets it with its user agents. Remember, this one's a user agent for Dirbuster. It's a tool, famous tool to find out the possible URLs, and this is his user agent. Means that this is being found by Dirbuster, and he is using that, and he is getting this thing and posting something. Okay. Okay. So we have interesting stuff here. Posting something. What is he posting? Let's find it out by using the PCAP file. Okay. Since it's a little bit big file, it's going to take a little bit while to load up. That's why you need to start with log analysis. The PCAP file actually I've provided you is even a really small PCAP file that you can find in the real cases. But I just wanted to keep you as simple as possible. So what I'm going to do is I'm going to look for frame contains. By the way, why I'm writing this? Already I gave the spoiler to you. I wish I asked you. Contains test2.aspx. Okay. So since I have a usual suspect, and I know that something is posted with test2.aspx, I wanted to take a look at what is being posted by this thing, so I can get an idea to where this shell.aspx is coming from, or even there might be more. Okay, so if actually I can filter out only the attacker's IP address in this PCAP file, but it's already been done because the original PCAP file was too big, so I just a little bit, make it smaller. Okay, so this is the head. Okay, this is the get file, get request that we see Dirbuster requested. Okay, that's also fine. And here is the head, here is the test. Again, get here. Anyway, so we found that this guy is using test2.aspx file to upload the shell.exe. So if you analyze the shell.aspx file, since we already have the file content here, so actually we can analyze from directly from here too. In here, when we look at the test2.aspx file, and okay, here it has a file upload field and also a button field. It's uploading a file, and if you look at for the bin directory, you will see that there is a CTF-DLL. If you do a reverse engineering, you will see that there is a function, but it's not checking for the file content. So that's why there is an unrestricted file upload vulnerability on this piece of URL. So he's using that to upload the shell.aspx file, so which is right here. If I look at this, this is really the attacker's shell or our shell, when we look at that, it's obviously saying that ASPX spy file. So there is an admin username and password protection in the file. So if you look at the content, it has a lot of capabilities to look for the directories, run for commands. So actually you can search for command here. It has some commands and also database connection capabilities, and all of these things can be possible to do that. If you're running the web application, you can see that this ASPX file actually has a lot of functionalities to run on a web server. So it's a backdoor definitely. So it's uploaded by the attacker to do some extra work. And obviously this aab.exe is also uploaded by either test2.aspx file or the shell. So when you responded to this case, you can see that there is a file ab.exe in uploads folder. That's a red sign. And when we see that, we actually shocked that he uploaded a text file and also, backdoor file. He was protecting these things with the password. So he was smart enough to, protect his shell for himself only. There was an embedded password in the shell file. Okay. So when you uploaded this thing to VirusTotal, you will see that there are a lot of, warnings that says this is a malware, it's a Trojan, kind of a Trojan, of course. So those are the things that we have found on the web server. Definitely in this case, we agree that we are in a position that this machine is compromised by an IP address, and also he used a known vulnerability on one of the, hidden tests page, and there was a vulnerability which allows an arbitrary file uploading. And then this guy uploaded a backdoor, and after a backdoor, he uploaded another file here to connect to the command and control center, right? So I need to know that whether this ab.exe is run on the machine or not. How can I know that? So in volatility, we can do this way. So what I'm going to do is I'm going to search for the connections, network connections. If I see that there's a process, actually what I'm going to do is simply list all the processes in the file. So what I'm going to do is ps list. So let's copy this. Now I have actually right here because that PDF doesn't allow me to copy things. Okay, so this is going to be my memory. By the way, I know that it's a Windows 2008 R2 respect 1, so I don't need to analyze what kind of an image file is this. I already know that this is a Windows 2008 machine. So let me go back to the inetpub and then web server here. Okay, I think we are good. And my volatility standalone is the one upper folder. So what I'm going to do is right here, I'm going to run volatility, and the command is going to be this one. So this is going to use the DC. Oh no, it's not DC. It's web server. It's supposed to be web server. Let me actually delete these things. web.server.memory. So this is going to be my file. I mean the memory file. So it's going to list my processes that is active on that machine. It's going to take a little bit while, and I can do the analysis for the PK file too. So when I look at it, I see that here is the ab.exe is available on my machine, right? So it's been started exactly the time where the attack, somewhere around. Remember, the attack started at this, close to this time. So we know that this guy ran the ab.exe on the file. So our suspected process ID is 2612. Okay, so PID is 2612. So I can get the network connections and also make sure that it's being connected to the command and control center. Let's use NetScan here. Yeah, what I'm going to do is exactly NetScan one. NetScan here, and I will grab. Let's not grab things. I can search for that if the output is too large. Okay, so created PID local protocol. So yeah, states, that's what I was looking for. Let's wait for that, and probably we will see that there is a state between connection, or at least an established state between my command and control center and also the attacker IP. So my process was ab.exe. Let's find it out right in this here. Sorry? Oh, yeah. Sorry, guys. Sorry. This is my working style. I usually keep the folders on top and then right here. So, okay. Let's see. Notepad. Interesting. This is actually that you should focus on. Notepad has a connection with another server. Actually, this is a good indication. There is no reason, right? Notepad shouldn't supposed to open a connection to another machine. By the way, it's the local IP address. 10.IP address is the local IP. So we understand that this guy used the notepad.exe to connect to somewhere else, right? That's it. Let's keep it in our mind, and let's look for the attacker's IP address, whether we have any connections to the system. Okay, so here's the proof. ab.exe 2612 the IP address, and there is a process ID. We have the established connection between my local server and also the attacker's 443 port. That's a clever idea. He is using 443 as a command and control center port. That's why you may not see that in the real cases. By the way, in my cases, when I look at that, it was using the HTTPS connection. That's why I couldn't find all the details and communication details in the PCAP file, although they are using the full packet capture. But HTTPS connection, I didn't have the private IP address of that communication. That's why I couldn't resolve that. But when I look at that, I see that, okay, there's a connection between these two guys. That means that there is something going on. So I can take a look at the size of the PCAP file, the communication, I can understand whether there is any potential data leakage. When I looked at, there was approximately 100 megabytes of communication between these two guys. So I clearly understand that this guy steals something from the server. I reported that these guys, and when I look at the SQL log file, remember there is a SQL log file. When I looked at, there are a lot of SQL commands, although the output is not printed, but there are a lot of SQL commands, and I understand that this guy, steals something from the databases, a lot of customer information, credit card information, and things like that. So we addressed that there was a data stealing problem here, and also this guy used this ab.exe. So interesting. So let's keep in mind that Notepad.exe have these connections. It's going to be useful for us, and interesting though, one of them is remote RDP port. Why Notepad.exe is connecting to the RDP port of somebody else, all right? So let's keep that in mind, and let's find exactly the same thing in the PCAP file. So here's the second chance. I wanted to prove that in PCAP file, I can see exactly the same connection. So first of all, I need to analyze this ab.exe file to find out what kind of IPs and ports are available in this one. So what's the first initial step that I can see the port and IP addresses? Let's assume that we ran that step, and then how can I find it in a PCAP file? You got the idea, right? So can you show me whether there is any such package? Yeah, right here. Exactly. So this is the proof that shows that my IP, my local IP address, the server's IP address 203, is connecting to the attacker's IP address and sending the very first SIM package. Where is it? Oh, okay, right here. The SIM package. So, and he sends the ACK package, and then of course the connection established and then running on. So this is how we can prove that this connection is established. Of course, you can follow the TCP stream and see the full communication. All right, and while we are here, let's take a look at some of the interesting stuff here. So this gives us a really good picture. Can you tell me what's wrong in this package? No, it's not encrypted, by the way.
Looks like
yes.
It's a exe file.
Yes. MZ, yeah. MZ, when it starts with MZ, that means this is something in an executable, and you can see that this program cannot be run in DOS mode. That is an executable, but what the hell is doing this executable? We already have the executable in the server side. Why? Yeah. So remember, guys, when attackers attack to a server, they first download the canvas, which has no executable payload, because otherwise, if you include everything in that malware, it's going to be easily detected by antiviruses. That's why they only download the canvas, let's say the engine that runs for the different payloads. And then this is dropper is the right word. And then this is the payload that's been transferred from the command and control center. And the dropper is saying that, hey, I'm in the machine. What do you want me to do? Do this. This is the answer from a command and control center and saying that I want you to do this. So if you analyze it, it's a Meterpreter payload. It's just saying that, migrate to another process like Notepad and whatever. So that's good. So that's how we can prove in PCAP 2. So we have completed another stage here. We proved that ab.exe ran on the machine. We already proved that these guys also are on the machine. We already looked at the PCAP file, memory file. Okay, yeah, I think we are in good shape here. What I like to do is when we analyze this thing, we need to know that if there is any connection. So let's go back to our attack scenario here. So we already agreed that our web server is compromised and there is an agent running on behalf of the attacker, right? So this machine is now under attacker's control. So we need to know that whether this guy is connected to the domain controller or Windows 2003. Connection, which is established by Notepad, and the port, if you look at it, the port is interesting for this way. And
so the other thing is I ran PS3 to see that Notepad is actually a sub from AB.
Perfect. That's what we're looking. So this Notepad process is different than the original Notepad. When you usually run a Notepad, the parent process usually Explorer exe. But in this case, this Notepad interestingly, the child of ab.exe, that's the proof that this notepad is executed by the attacker. Okay? So, perfect. Great. What's